Hello everyone. Very good
Hello.
evening to all of you. Yesterday we studied about the origin of solar system and the solar system as a whole, and about sun, right? So today we'll be dealing with two of the planets which are closer to the sun, which are Mercury and Venus. So can you see the slide?
Yes.
Yes,
Yes.
very good, very good.
It
So
is.
let's start. Yeah, it's about Mercury. Mercury is the first planet in the solar system, only about 60 million kilometers away from the sun. And it takes Mercury about 88 days to go around the sun. So it is taking the lowest time to revolve around the sun because it's closer to the sun. Yes. And it's also like it will take 58 days to rotate on its own axis, which means one day in Mercury will be 58 days on Earth. And if you have seen the surface of Mercury, like in the picture here, it is a Mercury, it looks a lot like the moon, our moon. Yeah. And Mercury is a heavy planet. Heavy planet in the sense not massive. It is the planet with least mass, but it is heavier in the sense it's high density. The density is very heavy, and the gravity of is about one third of the Earth. Gravity of Moon is one sixth of the Earth, right? Just like that, gravity of Mercury is one third of the Earth. Now, about the core of the Mercury, our core is actually a solid core, but the core of Mercury is still a liquid. Now, different gases are found in Mercury's atmosphere. Mercury's atmosphere, when we talk about it, is very, very thin. Such thin atmospheres are called exospheres. It's very tenuous. And this, everybody please mute your system. So Mercury's thin atmosphere contains hydrogen, helium, and oxygen. So the first prominent element is hydrogen, and then there is also helium, and then there is oxygen. Also, it has smaller amounts of sodium, potassium, calcium, and magnesium. It was found that only these three elements were there: hydrogen, helium, and oxygen. Later, it was found that smaller elements, mostly smaller amount of sodium, potassium, calcium, and magnesium. So the three abundant gases found in Mercury's atmosphere is hydrogen, helium, and oxygen. It is very hard to study about Mercury. One thing, it is closer to the sun. So if it since it is closer to sun, if we are observing Mercury from Earth, it will be difficult because there is a very high intense celestial object, which is sun, near to it. But still, and also we cannot look it at night, right? Because at night, we are on the opposite side. Actually, Mercury and Venus, they are ahead of us. So at night, we cannot see them. So mostly in Mercury's case, we cannot see them at all. So it's hard to study it from Earth, but still studies are going on. The radar studies are going on. But we have sent some probes to study more about Mercury. And these probes has found that all both the Earth studies and the probe studies, it was found that there is presence of water ice on the poles of the Mercury. So the question is, how can there be water on a planet that is nearly boils in the solar wind? It's so close, only 60 miles away from the sun. So solar wind will be the flux will be very large, right? Huge. So NASA scientist Thomas Surbecken note three possibilities. The first possibility is that there may be reservoirs of water ice in small areas of Mercury's poles. The second one is this, which means water could be as old as the solar system. It could be already there in the solar system and present in reservoirs near the um, poles. But don't think that this water is just like Earth's ocean. No, it's not like that. It's in waterized form, and it may be buried inside the crust of the. Yes. So the next thing is the water could have been brought by comets. Comets has water content in it, right? It's actually the one of the main component in comet is water ice. So maybe comets must have deposited water there. Or the third thing is chemical sputtering that could create water from the solar, wind, and mercury and rock. So the third one is due to this chemical reaction that could occur, the interaction that could occur between the solar wind and the Mercurian rocks, that could have been the reason. So, what is the real reason? We don't know yet. Now, because of its close proximity to the sun, the innermost planet Mercury cannot be studied from Earth against the night dark sky. Yeah, that's what we were talking about. And many astronomers and most people have never seen the elusive planet. Yeah, back in time, we didn't know that there is a planet called Mercury because we cannot see it in the dark sky, right? It's in the night sky. Astronomers used to look at the sky to see what all things are there in the sky, but we cannot see it in the dark. So, so this question was there. But later, it was found that such a planet is also there. Now, during daytime, in Mercury's daytime, I mean, when Mercury's particular side is facing the sun, then the ground temperature reaches of 740 degrees Kelvin. Look at that temperature, 740 degrees Kelvin. Even metals can be, you know, melted. And at night time, it plunges to a freezing of 100 degrees. So, what could be the reason why, even though it is nearer to the sun, the opposite side, the darker side, the night side of the Mercury is being frozen? Why? Because, see, why? If a ray is falling on a particular surface, of course, the temperature rises. But there is backscattering, right? So, if there is no thick atmosphere, what happens if there is no greenhouse gases present in the atmosphere, then this light will just won't get trapped inside the atmosphere but just escape to the space back. So that is happening in the Mercury. Since this, when it is facing the sun, a lot of rays, I mean, a large, huge flux of these rays are hitting the surface. But when it is coming to the darker side, what happens? And also, it takes days, weeks, and weeks to turn around. It takes 58 days, right? So, within that time, all the rays could be escaped from the surface. Then there is minus degrees. Mercury's rotation axis is aligned perpendicular to its orbital plane. Yeah, yesterday we talked about orbital plane. I don't know if you remember about it. See, Mercury's rotational axis. We know that Earth rotates in its own axis, right? But it has a tilt. But for Mercury and also for Venus, we will come to know about it in the Venus slide. Mercury and Venus, both they do not have a tilt. It's almost perpendicular to the orbital plane, which means they do not have a tilt. This tilt is the reason why seasons are there. Since this tilt is not there, Mercury and Venus they doesn't uh, experience different seasons like winter, summer, um, fall or spring. If you need more details on that, please note it down and I'll tell you after the slides. Yes. Now, at first glance, although one of the Earth's nearest neighbors, only one spacecraft, Mariner 10, has ventured near Mercury. Yeah, there are many other spacecraft, mainly Mariner 10. Otherwise, there are a number of spacecraft. Anybody knows these spacecraft or any spacecraft which has either flyby or studied about it?
Ma'am, Messenger?
Yes, that is right. Messenger is also there. Yes. So the first spacecraft to visit Mercury was NASA's Mariner 10. Yeah, so this was there, the Mariner 10, and Messenger missions have been the only missions. More the Mariner 10 and Messengers, and there is and some other flyby missions like Pepe Colombo or even Parker probe also just on the way to study about the sun. Maybe this satellite could study give data regarding um, Mercury too. But other than that, it's not possible. One of the reason is the orbit is very unstable because there is a huge thing there nearby, right? So because of that, it is hard to navigate the spacecraft. Now, at first glance, Mercury is airless, cratered surface that resembling the moon, but Mercury has unique surface features. It has many unique surface features like ancient intercrater plains, young smooth plains, etc. Now, Mariner 10 mosaics of Mercury. Here you can see mosaics in the sense when a satellite is taking picture, it's not taking the whole picture. If it is near to the planet, you know, in the field of view, the planet won't be fully photographed, but mosaics of these photographs are taken. What is the benefit of that? The main benefit is high quality image will be formed, which means the pixel will be larger. So more features in the surface can be retrieved. So you can see here the Mariner 10 mosaic, and the features are very much visible here. The craters, moon-like surface. Now these are the vital
Ma'am,
characteristics. Yeah.
if Mercury has so many craters, does that mean that its atmosphere is capable of having asteroids coming towards it?
It doesn't have any atmosphere. Like the atmosphere is very thin.
Or like,
Uh,
does it have gravity to pull the?
Of course, it has
Uh,
gravity. It has one third of the Earth's gravity. It has
so
mass. Yeah, the mean distance from the sun is 57.9 into 10 raised to 5 kilometers, 6 kilometers, which is 0.387 astronomical units. That is almost 60 million kilometers or 57 million kilometers. And the diameter is 4,879.4 kilometers. Actually, it's compared for Earth, it is 12,000 in the range of 12,000. For Mercury, it is in the range of 4,000. So, if you consider the Earth as one, the volume of Mercury is 0.054. Then the mass of Mercury is 3.3 into 10 raised to 23. And the surface gravity is 0.376. If you consider one is the gravity of surface gravity of Earth, then it is only 0.376. The rotational period is 58.65 days and the revolution period is 87.97 days. Now the mean temperature will be 166 degrees Celsius. And it doesn't have any natural satellites. If some questions are coming to your mind, please write it in the chat section. We will answer it at 8:30. Okay. Yeah. Now about the exosphere of Mercury. Mercury has an extremely tenuous atmosphere with a surface pressure a trillion times less than Earth. Actually, this type of tenuous atmosphere, just like we said in the previous slide, is called exosphere. And because the atoms in it rarely collide, the Mariner 10 identify the presence of hydrogen, helium, and oxygen in the atmosphere and set upper limits of the abundance of argon. So these are the elements present in it. And later it was found that in the previous slide, so that later it was found uh, trace elements of sodium, potassium, calcium, and magnesium. These elements are probably derived from the solar wind. Yeah, solar wind, the elements of the solar winds are similar. So it could have been from the solar wind that these elements are there in the atmosphere. Later, Earth-based telescopic observation detected sodium and potassium in quantities greater than the elements previously known. Now about sodium and potassium, it could be released from the surface rocks. Sodium and potassium are not in the solar wind, right? But then how could these elements are seen in the uh, Mercurian surface? Maybe when the solar wind interact with the rocks in the Mercury, or when meteoroids are collided on the surface. These could be the reasons why trace elements, trace quantities of sodium and potassium and calcium. Now, so why there is, the surface, why the atmosphere of Mercury is very thin? Why, why, Earth-like atmosphere is not there in Mercury? One of the reason is it depends on the velocity, like escape velocity of the planet. So what is escape velocity? It is the minimum velocity with which you know um, an object
This
can
this
go from.
escape
Yeah,
velocity.
it's okay. I'll tell you about that. You can um, ask your doubts in the later sessions. So
Okay,
escape
boss.
velocity. Yeah, thank you. Escape velocity of the planet is the minimum velocity with which an object can escape from the surface of Earth or any planet. Okay, so that it will go to a particular orbit and revolve around the planet. For example, escape velocity of Earth is 11.2 kilometers per second. In Moon, the escape velocity is actually in the range of 2 meter per second. Okay, so since 2 meter per second and all, it can be easily attained. The particles can easily attain this speed, this velocity, so they escape into the space. So why Earth atmospheric particles are not escaping into the space in a large amount? It's because the escape velocity of Earth is larger. It's actually 11.2 kilometers per second. It's hard to achieve, right? But in the case of Mercury, since it is a smaller planet, it doesn't have that much mass to have a great escape velocity. One of the reason is that, and the second reason is the speed of the gas atoms and molecules, which depends on temperature of the gas and mass of gas. So that is the other thing. Let's see. If the temperature is more, then the velocity of the atoms or particles are more. Just like us, when it is a high temperature thing, we need to move fast, right? Otherwise, these atoms will get more energy, and they have to. When there is more energy, they have to move faster. It's a common physical and chemical, interactions that we study. And when it is the mass of gas is huge, then of course the velocity will be less. That kind of relations are there. So all these are the factors that points out the presence of atmosphere in a planet. So considering all these facts, it is actually not a surprise that Mercury doesn't have a thick atmosphere. Now, this is the structure of Mercury that is compared to the Earth. The left side you can see that is Mercury, and the right side it is Earth. Consider the inner layers of Earth. That is, we do have a crust, then a mantle, and a core. We call it crust is there, then upper and lower mantles are there, then outer and inner core is there, right? So just like that, even Mercury has also different layers in it. It's not just a ball of rocks, but it has layers within it. It has a core, a mantle, and a thin crust. So the core of Mercury is actually, when compared to the size of the planet, it's actually having more diameter when compared to the size of the planet. Actually, it is less, but since the whole planet is having a lower radius than that of Earth, but compared to that, the core is actually bigger. Okay, there are many reasons why this core is bigger. Maybe it is, some scientists say that Mercury must have been a bigger planet, but the outer crust area must have been accreted by the sun, so that now the planet seems small. So the core of Earth is actually 3,470 kilometers, but the core of Mercury is 1,800 kilometers. Considering the size of its size to be only two 2,440 kilometers, the radius, this is almost the whole planet itself, right? The whole planet itself is a core. Yes. I hope that is, you understood that, right? Do I need to uh, say it again?
No, ma'am, I
No,
understood.
ma'am.
Okay, let's move to the next slide. So the calories basin. This is actually an important basin. You can see here the rim of the calories basin. It's actually having a diameter of 1,300 kilometers. So some huge collision must have happened in a previous era that could create such a huge crater on the Mercury. And see, just opposite side of that impact. Here it is the impact, and here a lot of hilly lineated region is there. So there is this theory that when the impact happened here, these region mountains are there, and here also mountains are, which means this ejected rocks must have been fell here, okay. And then in the opposite side, it must have been, the compressive wave which traveled across the planet must have created the hilly and lineated region in the opposite side. So these are the effects of the formation of the calories basin. Okay, moving to the next slide. Yeah, sorry. The linear cliffs called scarps, hundreds of kilometers long, were probably caused by contraction and wrinkling during cooling of the planet. These are the linear cliffs here. See, when yesterday we studied that when the planets were formed, the surface, it was not um, finalized, right? It was not stable. Continuously, events were happening. For example, on Earth, a lot of events. It was completely filled with magma once, like a lot of heat was there. Temperature was very high at that time. But so here you can see a feature called linear cliffs that are called the scarps, which are hundreds of kilometers long, as you see in the picture, and they were probably caused by the contraction of England during the cooling of the planet. Now, in the coming slides, let's have a look at the physical properties of Mercury. It includes the orbit. Yeah, we talked about the orbit. It is a very elliptical orbit, and at perihelion, perihelion is the closest point in an elliptical orbit, and aphelion is the farthest point, and perihelion is at about 46 million kilometers. So it comes close to some 46 million kilometers, and the aphelion is 77.3 million kilometers. So on an average, we can say some 60 kilometers, million kilometers. Now the rotation, it takes almost 58, 59 days for one day, and 1 year is actually how many days?
365.
No, for us, Earth, it is 365 days. For Mercury, it is
88 days.
88 days. Very good. Now, as a result of planet's slow rotation and on its axis and rapid movement around the sun, actually there is a delay on day. Big day in the sense from one sunrise to the next sunrise, it takes actually 176 Earth days. But it rotates in 59 days, but it takes this much days for one sunrise to come after the other sunrise.
Ma'am, how is it possible that it rotates 59 days, but sunrise to sunset it is 176
It's not, it's because it's
days?
always slow revolution. I mean, so slow rotation and it's rapid revolution around the planet. So, for example, it's not just the rotation which gives us this thing, but also in between we are revolving around it, right? So that could create maybe let me find some animation to show you that. And after this, lecture, I could show you. Let me please make me give me a reminder. Then I will show
Okay,
you
ma'am.
that. Yeah.
Okay.
Let me see if it is available online. Yes. Now the composition of Mercury, that is the second densest major body in the solar system after the planet Earth, and its density is slightly less than that of Earth. Why the density of Earth is larger? Because the core of Earth is actually made of iron and nickel. That's why it's heavier. Now, about the surface of Mercury, it consists of cratered terrain, just look like the moon. Now, the scans of Mercury made by Earth-based radar indicates that craters at Mercury's poles contain water ice, and the floors of the craters are permanently shielded from the sunlight, so the temperature never gets high enough to melt the ice. So that is the reason why there is the presence of water ice in the poles. Yes, and Mercury again. Although Mercury is close to the Sun, Venus is the planet with the higher atmospheric and surface temperature, because it doesn't have a proper atmosphere. Whatever light comes, it will escape back to the sky. Yes, we talked about atmosphere. Yes. So this is a slide for Mercury. And let's move to the next slide, the Venus slide. I hope the screen is visible to you, right? Venus?
Yes, ma'am.
Yes. Okay. So first, let's have a look at the vital statistics of Venus. Venus has a diameter of 12,104 kilometers, which is actually near to the a slightly less diameter of Earth, but Earth's diameter is closer to that, right? It is 12,742 days. It's only a variation of almost 600 kilometers. Yes. Now the mass of Venus is 4.8 into 10 raised to 21 tons. And then mean density is 5.25, and rotational speed is, so this is important, okay, rotational period and revolutionary period. Rotational period is 243 Earth days. It takes 243 days to rotate on its own axis, which is actually more than a year. 1 year in Venus is just 224 Earth days. So a day is actually larger than, longer than a year. Then you talk about surface gravity. Surface gravity is actually um, 9.8 meter per second square for Earth, and it is closer that 8.87 meter per second square for Venus. So all these characteristics, similar characteristics, make Venus the twin sister of Earth. So let's have some of the basic information regarding Venus. Like Venus is the second planet from the Sun. It is named for the Roman goddess of love and beauty. That Venus and Earth are often called twins because they are almost similar in size, mass, density, composition, and gravity, etc. Now, Venus is one of the terrestrial planets. Yeah, four planets are considered for the as the terrestrial planets: Mercury, Venus, Earth, and Mars. They are rocky planets. Yes. So, and one more interesting factor is its axis is nearly vertical and its orbit is nearly circular. Due to these two facts, um, Venus, just like Mercury, also doesn't experience seasons. Earth and Mars experience seasons because there is tilt in the rotational axis. Now, a day in Venus actually lasts to 43 Earth days. That's how long it takes Venus to make one rotation, while a year on Venus, its revolution period around the Sun, is shorter at just 224.7 Earth days. Now there is this question like, can life exist in Venus? Actually, the question is tricky because Earth-like life cannot be found in Venus. We are not, we are actually having a short range of pressure, right? We can't even go without a suit to the upper atmosphere and to without similar to that, we need such equipment, such suits and equipments for us to go in depth of ocean. In ocean, the depth as depth is increasing, pressure increases, right? As 10-meter we going down the ocean in the sea, in the water, I mean, then each 10 meters, one bar is increased, one bar pressure is increased. So that is there. So considering all this, we cannot live like that. We can actually easily live at this pressure. The surface of Earth, we consider that pressure is 1 bar. Bar is the unit of pressure, one of the unit of pressure, and at uh, the Venusian surface, it is actually 99 times that of the Earth's surface. Yeah, we will come to that in the coming slide. So it is not possible to live at that kind of a pressure. And the second thing, even though life is formed there, the temperature, the surface is having a huge temperature. It's the planet with the hottest temperature. It's the hottest planet. And the next thing is the wind. You know, in the equator, the usual winds there actually has some 400 meter per second range in speed. Okay, so these are the factors by which we say that Venus cannot host life. But it is said that, during one satellite, actually, when it was flying by Venus, we got some phosphine gas in it, like we detected phosphine gas. It could have been life, a doubt that life is there in the Venus, but later it was found that there was some erroneous data given by the planet. Now, yeah, the air pressure on the Venus surface is extreme. It's about 90 times higher than the pressure at the sea level here on Earth. So, in other words, the pressure on Venus is about the same as the water pressure on Earth, about half a mile. That is almost say 1 kilometer under the ocean. So, and about the volcanoes, there are more volcanoes in Venus than on any other planet in the solar system. So consider that. And so the surface is almost, continuously, maybe eruptions can happen, the volcanic eruptions, then cyclones, continuously cyclones like winds are flowing. So it's actually practically the hell in solar system. Now about the magnetic field of the um planet. It doesn't have a magnetic field. Earth has a magnetic field, right? Why does Earth has magnetic field? The reason is actually Earth's outer core is liquid. So these charged iron and nickel, they are actually revolving as the rotational speed of Earth is less. It's just 24 hours, right? So it just rotates faster. And when the Earth is rotating faster, this outer core, which is in molten form, it also moves. When charged object moves, then magnetic field is created. When an electron is standing still, considered an electron which is just not moving, so it produces electric field. When it starts moving, both electric and magnetic field is produced. So just like that, when the charged atoms in the outer core is moving, a magnetic field is produced, and a total, effect of magnetic field looks like if there is a bar magnet in the center of the universe, just like it's an imaginary thing. So this effect is called dynamo effect. Because of this, Earth has a magnetic field, but Venus, it doesn't have a magnetic field. One of the reason is since it is having a very slow rotational speed. Now, Venus has a highly pressurized atmosphere as well, consisting mainly of carbon dioxide and with clouds of sulfuric acid. And scientists have only detected trace amounts of water in that. So this is the next thing. The occurrence of greenhouse gases at the surface of, the atmosphere of Venus. On Earth, we know that the temperatures, we call it global warming, right? So whenever the amount of greenhouse gases, for example, carbon dioxide or chlorofluorocarbon, such greenhouse gases, when they are increasing, what happens? The temperature increases because the rays will, come to, continuously. Solar rays are spread from the sun to every side, so it reaches the earth. So what happens when greenhouse gas is present in the um, atmosphere? Then it will hold this temperature, this energy. It won't give this energy back to the space. Backscattering won't happen, even though rays have been backscattered by the surface. It is, you know, actually grasped by the greenhouse gases present. You may have already, experienced it. For example, when it is cloudy, uh, but not raining, it's just cloudy, then temperature is actually more. You may have experienced that anyway. So this is the reason why it is the hottest planet. Mostly carbon dioxide and clouds of sulfuric acid. And scientists have only detected trace amounts of water in the atmosphere. Now, the presence of Venus in the sky is actually it's a nice thing to view because after sun and moon, Venus looks brighter in the sky. Every morning in the eastern sky, we can see the Venus. Even now, it is almost past twilight. So tomorrow early morning or in the evening, you look at the sky. If you're looking at the early morning, you just look at the eastern side of the sky, and some 6:30, 6:30, 6 o'clock, or before sunrise, I mean. And after sunrise also you can see that. And in the evening, some 6:30, 7 o'clock, that time, if you look at the western sky, you can see Venus. So Venus is visible only during morning and night, and we cannot morning and uh, early morning and evening. We cannot see Venus at night because it is ahead of us. And yeah, that's why it was called morning star and evening star. Now, in the ancient times, the evening star was called Hesperus, and the morning star Phosphorus, Eosphorus, or Lucifer. Because at that time, people didn't know that these are different planets. No, the same one. People thought it is different. We can see the bright thing in morning, and at that time, people know that this. And later, when astronomers found it, yeah, all these named different of the same thing, Venus. Now, there is another thing called phases of Venus. Just like that of the moon, we can see different phases in for the Venus when we look it from the Earth. So here in the picture, you can see a photo collage of the planet in planet Venus, as it travels from outside of the sun to the far side. You can see like this. When it is near to the, in our side in the means it's closer, we can see it as a crescent. And if it is far away, uh, near to the sun, then we can actually see it as a full planet. Now, this is an interesting thing. Have you seen the transit of Mercury or transit of Venus? But it's called, um, consider the sun's disk. Since Mercury and Venus are friend of us,
Not audible.
am I audible now?
No, not clearly.
Hello, what happened? Am I audible now?
Actually, ma'am, your
Yes.
voice is cracking.
Yes.
Ma'am, my voice is also feeble.
What about now?
Now it's clear.
Okay, very good. Hopefully, my voice is audible now, right?
Yes. Yes.
Yeah, very good. So I was talking about the transit. So whenever consider transit disk, so whenever these planets friend of us, like Mercury and Venus, when it moves um, through the solar disk, like if the sun is there, it's moving actually. But when we look it from Earth, we feel that it is moving in front of the sun, right? Sun's disk. If we see like that, you'll feel that we can see that. Otherwise, before before coming to the sun, we cannot see it dark, right? But whenever it is in front of the sun, we can actually. So such an event is called transit. So Venus is rare among the planets in that we can see it crosses in front of the sun. Only Venus and Mercury do this from the vantage point of Earth. I mean, if you're looking from Earth, we can see the transit of Venus and Mercury only. But if you are looking from the Mars, you could even see the transit of transit of Earth. And if you're looking from Jupiter, you could see transit of all the inner planets. Okay. Now, the motions of Venus, different. Yeah, we've already gone through that the Venus circles the Sun once every 224.7 days in a counterclockwise direction. So that is there. So Venus is the only planet which rotates counterclockwise. All planets revolve in same direction, but it is Venus who rotates in the opposite direction, the counterclockwise direction, which is the same direction as the other. Yeah, it rotates, but revolution is fine. Revolution, it is just like any other planet, it is moving. Now, Venus rotates on its axis the opposite way that most planets rotate. That means on Venus, yeah, all planets rotates from west to east, right? If, for example, Earth rotates from west to east. So since it is moving towards east, we see sunrises, moonrises, everything from the eastern sky. But for Earth, it is sorry, for Venus, the sun rises in the west and sets in east. Now the magnetic field of Venus. What do you think? Will there be magnetic field for Venus?
No.
Yeah, actually, no. There won't be magnetic tail for Venus, but there is another thing called a tail can be there for Venus. It's called a magnetotail. It doesn't have to do anything with the magnetic field, but the atoms there, when it interacts with the atoms in the atmosphere, when it interacts with the solar wind, which is moving really fast, so sometimes, I mean, in the brighter side of the Venus, some tail-like formation can be seen. It's a rare phenomenon, but it can be seen. But other than that, there is no magnetic field on Venus. It is a world that does not inherit or generate a magnetic field. In part because of its slow rotation. It takes 243 days to rotate on its own. And its predicted lack of internal thermal convection and any liquid metallic portions of its core could not be rotating fast enough to generate a measurable global magnetic field. Now, yeah, this is the slide. Like, despite the absence of large protective magnetic sphere, why it is protective? Because it protects the solar winds coming towards us. I mean, have you seen this phenomenon called in the polar region? We can see auroras. Actually, auroras are produced by the interaction between solar wind and the magnetic field of Earth. So actually, our magnetic field is protecting us from from
UV
the
rays.
harmful effects of sun rays, okay, and solar wind. But this for Venus, it's not there. So Venus environment does not exhibit a number of similarities with planets such as Earth. But the latest surprising example is the evidence of magnetic reconnection, the Venus-induced magnetotail that we just discussed about it in the previous slide. Yeah, the atmosphere of Venus contains 96.5% of carbon dioxide and 3.5% of nitrogen. For Earth, it's nitrogen, which is 78.1, and there is 20.9% of oxygen. Now let's have a look at the exterior and interior traits of Venus. Venus has a thin crust, a mantle, and a core, just like that of Earth. That is actually similar. Now, the research and exploration to the Venus.
Ma'am,
Yes,
ma'am, can you please show the previous slide?
this one.
Ma'am, the previous one. Yes, ma'am. Thank you, ma'am.
No
Done, ma'am.
problem. Thank you. Research and exploration. So in 1962, NASA's Mariner 2 came within 21,600 kilometers, miles of Venus, making it the first planet to be observed by a passing spacecraft. So Venus is the first planet that we actually um, landed and explored. Not human landing, but this capsules have been landed there. You know, different landing have been there. Now, in 1967, there was Mariner 5, and 1974, there was Mariner 10. Now, there is this satellite, Vega 1 and 2. It was sent towards Halley's Comet in 1984, but it also flew by Venus and released descent capsules. Descent capsule means which land on the which go down the atmosphere of which will go to the bottom of the atmosphere and land on the surface. And several of these probes successfully reached the planet's surface. 1978, Pioneer Venus 2 sent 4 probes to the surface, while the remaining craft explored the upper atmosphere. 1978, this orbiter Pioneer 1 measured the upper atmosphere for 14 years. Then there was another probe called Magellan probe, which was launched towards Venus in 1989, which transmitted radar images of the planet from 1990 to 1994. And in 2005, the ESA's Venus Express spacecraft was there. It was a mission to Venus, and it was equipped with instruments designed to study the structure, chemistry, dynamics of the planet's atmosphere, particularly its hurricane force wind and its cloud system. We carried out the first infrared instrument. Infrared instrument means if you are using, if you're anything related to temperature, you can easily use infrared sensors. And so this Venus Express studied the surface of Venus in infrared wavelengths. And due to this, the advantage of using infrared sensors is it can see through this temperature, high temperature things, the hottest things, the clouds won't affect it. It can penetrate through the clouds and then see the features. Now, there are some trivia details regarding Venus. Let's have a look at it. One of it is the global warming on Venus that has caused the surface temperature to rise with nearly 900 degrees Fahrenheit. It is enough to melt lead. Now, look at the wind speed in Venus. Winds swipe across Venus at super fast and speeds that can reach 450 miles an hour. That is 724 kilometer per hour, and it is middle cloud layer. In its middle cloud layer, actually, the Venusian winds are faster than the speediest cyclone tornado. Since it is very bright, it's sometimes often mistaken for a UFO. UFO is an unidentified flying object, just like ET, extraterrestrial spaceship, etc. It's nothing like that. Now there is this fun fact that Venus is the only planet in solar system which is named after a woman, the goddess of love and beauty. And so, all these features on the surface of the Venus, just like the mountains, the valleys, the ranges, etc., they are named in female characteristics. Names are feminine. For example, there are a set of canyons called Devana Chasma. It was named for Czechoslovakian goddess of hunting. And then there is Tondi Chasma, named after the Bengali goddess of wild animals. Then there is this mountain, which is Kopaketi Mounds. It's named after the Inca lake goddess. Then there is this irregularly shaped crater called Petera. They were named after the famous woman, including the birds Petera, named for Leo Tolstoy's wife, Sofia Andreevna Beers. Then there is Keller-Patera, that is named after Helen Keller. Yes, so these are the fundamental details regarding Venus. Okay. Thank you, everyone.